So this is the video for Core Practical 1, which will be investigating the relationship between force, mass and acceleration. So to perform this investigation, we need some specialist equipment, which is set up in front of me right here. So this investigation is all to do with Newton's second law. To do that, we're going to investigate how force and mass will affect acceleration. To see this effect, we're going to use a car travelling down a ramp, and we're going to try to look at how its speed changes and the time it takes between two different points. So for this investigation, the main part of our equipment is this track. It's slightly raised, so it's not flat, so you can see it's slightly raised, it's one here, because what we want to do is we want to eliminate the effects of friction in this experiment, and the weight of the car being slightly raised will eliminate and will compensate for that frictional effects of the car's tyres on the track as well. Moving along, we have these two devices here which are called light gates. The other side of the light gates has a beam of light which is shone from one side of the arch to the other, and as that is disturbed by anything, it will trigger at the front on the stopwatch at this point here, and then as it goes through the second light gate, it will then stop that stopwatch, so we can measure the time between these two light gates here. On the car, which is here, we have to make sure that we've got something that will trigger those light gates, and that's why we've attached the card here to it. At the very front of the car, we have a thin bit of string which is attached to a mass the other side. Now, because we have raised the ramp up, the only force that's going to cause any sort of acceleration to the car will be that falling mass. And for health and safety, we've kept crumpled paper in the box at the very bottom. To do this experiment, we could change two things. The first thing that we could change would be the mass of the trolley itself. And to do this, what we would need to do is keep adding masses, these 50-gram masses, each time into the back of the car, like this. And then we could investigate how the mass of the trolley will affect acceleration of the car as we keep adding masses. Now, to do this, we would need to make sure the mass at the very end remained the same. We couldn't change those masses at the other end. The second way we could do this is if we started off with all of the masses in the back of the car and then transferred those masses to the mass at the end, making sure that we kept the mass in the system the same. Okay, so I couldn't take off the masses here and then leave them out. I'd have to take them out of the car and then place them on the end there. And what we would be investigating there is the force rather than the mass of that we added into the back of the car. So two things that we can change are the mass and the force. The two things that we can investigate are force and mass. We're just going to look at how you would investigate mass and the mass of the trolley at the moment. So the very first thing that we need to do is take the car and record the mass of that car. So now that we've measured the mass of the car, that's very important, because when we start adding masses into the car, we need to know the total mass, not just of the masses that we add in, but of the total system, so the car and the masses themselves. Now, before we perform the experiment, I just want to show you in more detail how the light gates will work. So as I said before, the other side here, we have a beam of light that if it's disturbed, so as it goes to the first one, you can see it will trigger the stopwatch to start. As it goes through the second one, it will stop the stopwatch. And because of this, we can therefore measure the time it's taken the car to go from one light gate to the other. You could use a stopwatch to measure the time between those 2 points, but this will eliminate human error, which is effectively where we make mistakes recording the time. So the light gates will be more accurate and they will reduce the human error. So I'm just going to reset the stopwatch. And then what we want to do from this experiment is we want to calculate the acceleration. So as you know, the acceleration equation will be final velocity minus initial divided by time. Now, what we'd ideally like to have in this practical is the data logger attached to the light gates. Now, what the data logger will do is if we tell it how long the piece of card is, it will measure the starting speed as it goes through the first light gate. It will measure the final speed as it goes through the last light gate. And then as long as we know the time between, we can therefore work out the acceleration. We haven't got the data logger with us today, so what I'm going to show you today is an alternative method of how you could do this. So what you could do instead, if you didn't have a data logger, is you'd have to make sure that you record a starting line, so the same point where you dropped that car from, and all you would do is you'd add masses in, and then you'd record the time between the two different light gates. And then we can see the effect on the time by adding more and more masses as we go through. So before we start the experiment, we need to make sure that we make a starting line on our ramp to make sure that each time we do the experiment, it starts from the same position. And then what we're going to do is we're going to do the experiment, each time adding the 50-gram masses to see how that would affect the time that the trolley takes between the first light gate and the second light gate. So we're looking at adding more masses to the car, and how does that then affect how long it takes to travel from one light gate to the second light gate. Okay, so the first one I'm going to do is without any masses in there. So as you can see on the stop clock, it's taking 0.65 seconds to travel from one light gate to the other. So as you can see, I've taken the trolley back to the start line. I've now added a 50-gram mass at the back of the trolley, and I'm going to see if that affects the time it takes for the trolley to travel from one light gate to the other. So as you can see on the stopwatch, it's now taken slightly longer at 0.72 seconds to travel from one light gate to the other by adding the masses. Now what I would do now is each time I've done that experiment, I would do it 3 times each mass to make sure that my experiment is repeatable. So we're now going to talk about the results. Now from the practical, we were looking at the time taken between the 2 light gates, how that was affected by the masses that we added to the trolley. Here are the results that we collected for you for that experiment. And as you can see, the time taken for it to go from one light gate to the other would get longer as you add more masses. And it's because of Newton's second law that this happens. Now, Newton's second law is force equals mass times acceleration. Now, if we rearrange that equation to get acceleration equals force divided by mass, you can see that if you increase the mass, the acceleration will go down. And the reason for this is the force that's on the actual track is coming from the weight of the mass at the end of the pulley, which is constant. We didn't add any masses to it, it remained the same. So if we go back to that equation that we've just rearranged, force over mass equals acceleration, you can see that if the force, the top number, stays the same, but the mass increases, acceleration must come down, and we say that's an inverse relationship. When one of them goes up, the other one goes down, we say that's an inverse relationship. So more masses that we had will affect how quickly it goes from one light gate to the other. Now, if you had a data logger, you could show this by actually performing the calculation to work out acceleration. So as you know, acceleration equals final speed minus initial speed divided by time. The data logger would have worked out the initial and the final speed for us, and then we could divide by the time taken between those 2 light gates, and what we would have seen, the more mass that we had, the lower the acceleration would be. The alternative to this experiment, which we didn't do today, would be to keep the masses in the system the same. So whatever mass we've got in the back of the trolley, we then transferred to the end of the pulley, the mass that was the end of the pulley, and that would affect the force, because if we add more masses, weight is going to increase. So it's going to be pulled down the ramp quicker. And what we would see in that instance is a relationship where if we increase the force, so we add more masses to the end of the pulley, the acceleration would also increase as well. And we can also see that from the equation F equals ma, where we make sure that we've got acceleration equal to force over mass, and as that force number increases, so should the acceleration, because the masses remain the same in the system. So at the end of this core practical, you should now have an understanding of how mass affects acceleration, and how force will affect acceleration.